Hi everyone, welcome to my channel. I've started a personal DSA challenge where I'm solving 5 problems per pattern, covering 180 problems in total. I'll be posting one video per day explaining my thought process from brute force to optimized approach. In today's video, we will work on 2 sum using the brute force to optimization pattern. So the problem states that we are given an array of integers and a target. We need to return the indices of two numbers such that their sum is equal to the target. We are also told that we will only have one solution and we may not use the same element twice. So the most straightforward approach is to check all the possible pairs in the array and see if their sum is equal to the target. For that, let's start initializing a variable with the length of the given array, and we will check for all possible pairs. For that, we need a for loop to iterate all over the given array, and we also need another for loop where this for loop starts from I plus 1 because we may not use the same element twice. And we'll iterate this through the end. If this current pair nums of I plus nums of j, if this is equals to the given target, then we will straight away return the indices, because we are told that we will have only one solution, so we can simply return it. Otherwise, at the end we will return empty. Let's run the code. And this works. This involves two nested loops, so the time complexity would be O of n square and the space complexity would be O of n, because we did not use any extra space. This code works, but it is not optimal. So looking at the constraints, the array size can go up to 10 power 4. So the brute force approach, which is taking O of n square, should not be, or it may not be efficient for larger inputs. So that motivates us to look for a linear time solution. So if we observe closely, for every number, we are repeatedly checking whether its complement exists in the given array. So instead of searching for the complement every time, we can store this number, which we have already seen, in a hash map, and then we can look them up in a constant time. Let's write the code for that. For this, we need a hash map. Integer comma integer. Let's call it map. Now we would be only iterating once through the array. Plus plus let's call this complement, which is target minus nums of I. So now we are searching for this complement in the given map. If this map contains key of complement, then we will straight away return the index of that complement and the current index. If it is not present in the map already, then we would simply put it in the map. the index. And we would return this. Let's run the code. Now let's submit it. It is accepted. So this reduces the time complexity to O of n, since we traverse through the array only once, and the space complexity would be O of n because of this hash map. And this approach also covers the negative numbers by itself, no need to take special care, because the constraint says that we will get the negative numbers for target and the element. So this approach works for negative numbers as well, and since we check the hash map before inserting the current element, we are not using the same number twice. This is also taken care. So this problem is a classic example of how we start with a brute force solution, and then we optimize it by storing the repeated work by using some extra space in the form of a hash map. That's it for today. In the next video, we'll continue with best time to buy and sell stocks using the same pattern. Thank you for watching.